My, Myself, Wesley Jacob, Assistant Professor, Rohini College of Engineering and Technology. In this video session, I am going to deal on the subject Additive Manufacturing CME 339, Unit 4, Powder Bed Fusion and Material Extrusion. So in this video session, we are going to deal on the topic Selective Laser Sintering. It is also called as SLS process. This SLS process was established in the year 1987 by DTM Corporation, and it is a first commercial machine in 1992. DTM was bought over by 3D Systems in August 2001. First, we shall see about the principle of SLS. In this process, the parts are built by sintering when a CO2 laser beam hits a thin layer of powdered material. The interaction of the laser beam with the powder raises the temperature to the point of melting, resulting in particle bonding, fusing the particles to themselves on the previous layer to form a solid. The building of the part is done layer by layer. The next layer is then built directly on top of the sintered layer. After an additional layer of powder is deposited through a roller mechanism on the top of previously formed layer. This figure shows the unsintered particle. The particles are closely packed. The particles agglomerate at temperature above one half of the absolute melting temperature. As sintering progresses, neck size increases and pore size decreases. The figure shows the SLS process. So here there are three systems. One is the roller mechanism. The roller mechanism will load the powder material in the build platform. So next is the laser beam, which cures the powder material, which will be the thermoplastic material. So this SLS process also comes under the layer by layer deposition of material, which is a main principle of the 3D printing technique. So the process is a thin layer of heat fusible powder is deposited onto the part building chamber. The bottommost cross-sectional slice of the CAD part under fabrication is selectively drawn on the layer of powder by a heat generating CO2 laser. The intensity of the laser beam is modulated to melt the powder only in areas defined by the part's geometry. Surrounding powder remain a loose compact and serve as support. An additional layer of powder is deposited through the roller mechanism. This diagram shows the 3D view of the SLS process mechanism. So the materials which can be manufactured using SLS processes are polyamide. The polyamide trade name is Durafoam, is used to create rigid and rugged plastic parts for functional engineering environments. The next material is thermoplastic elastomer. It is a flexible rubber-like parts, can be prototyped. The material is impermeable to water and ideal for support shoe applications and engineering seals. Next material is polycarbonate, an industry standard engineering thermoplastic suitable for concept and functional models and prototypes. Investment casting patterns for metal prototypes and cast tooling. This SLS process can be used for nylon material. It is one of the most durable rapid prototyping materials currently available in the industry, and it offers substantial heat and chemical resistance. Next, this process can be used for metals also. Polymer coated stainless steel powder is can be used. Trade name laser foam ST100. The material is excellent for producing core inserts and pre-production tools for injection molding prototype polymer parts. The material exhibits high durability and thermal conductivity and can be used for relatively large scale production tools. This SLS process can be used for ceramic materials also to produce complex sand cores and molds for prototype sand castings of metal parts. Next, the process parameters in SLS process. Properties of powdered materials and its mechanical properties after sintering. Accuracy of the laser beam scanning pattern. Exposure parameter, resolution of the machine. Next, the advantages of SLS process. Good part stability, wide range of processing materials, no part supports required, little post processing required, no post curing required, advanced software support. It allows for streamlined parts scaling, advanced non-linear parts scaling, in progress part changes, build report utilities, and is available in foreign languages. Disadvantages of SLS process: large physical size of the unit, high power consumption, poor surface finish. Concept models, models and working prototypes. Next, the applications of SLS process can be also used as polycarbonate patterns in rapid casting, in metal tools as rapid tools, direct rapid prototype of tools for molds for small or short production runs. So this is all about the SLS process. Thank you.